If you are new to the channel, then subscribe the channel and press the bell icon for further notification. Okay student, welcome you all to this new lecture in GATE EM theory series. So today we will be solving again 5 questions starting from question number 11 to up to question number 15. Okay, then let's try to solve these questions. Okay student, if you come to question number 11, so what they are asking here, the figures show diagrammatic representation of the vector fields xyz respectively. Which of the following choices are true? Now this is very concepts of how physical meaning of divergence and curl I have explained to you in that calculus, vector calculus. So you can check again, that is how Carl was giving rotational effect. Because you see, you place a body over here and you see what this, suppose these are all force, you treat it all like a force, and you place a paper of this fashion or something. Suppose this pencil I have placed here. So this electric field, what it will do, it will push it to this direction, but it will not make the rotation. But if I place this one here, it will push it in this way and it will rotate it. So this object will get a rotational effect here. Here it is not rotation, just sliding. These forces will push him to go this side, but here it will force him to rotate, so it will rotate. Here also if you place it in this way, it will force him to rotate like this, you can see. So these two are having rotational effect, so obviously curl will not be 0 here. So curl of y, curl of z is not equal to 0. That is option C. By seeing it you can directly give answer. Curl of y and curl of z should not be equal to 0 because both are having rotational effect. If I place something, this vector will, if I place something on this field, this vector will create a rotation on that object, a rotational effect. And you can think of divergence. What was divergence? A box was there, some fluid was coming, some fluid was going out. So total number of fluid coming, going. If it is 0, then divergence is 0. If it is not 0, positive, that means something is there. You can see something is there. If you put a box over here, you can feel that something is coming out of here. And what is coming out is positive because everything is coming out. So obviously there is a source inside. So the divergence will not be 0 there also. But here if you place an object, here you can see if I place this object, this was my second one. So if I place an object, so whatever coming, whatever going out is same. If 10 liter coming, 10 liter is going out. So nothing extra is coming out of it. So what is total coming out of this box? If I place a box, 10 out minus 10 in, so 0. So that's why divergence here and here will be 0. That you can think of in this way. Here you have to check again whether it is 0 or not. Something is again coming. If you place a box, something is again coming out of it. So here it is not sure, but here it is sure. It is divergence is 0. But they are not asking which one is 0, they are asking which one is not equal to 0. So that is for sure, these two will be not equal to 0, this one because something is coming out of it. So obviously this divergence will not be 0. So 11 is option C, based on basic concepts on curl and divergence. This was a question of 2017. So 12 we have discussed yesterday. So if it is electrostatic field, if it is a static electric field, then curl of that field is 0. That means there will be no rotational effect of that electric field. So it is true. Now if you come to 13, what they are asking, the VWQ stand for the voltage energy charge that can be expressed as, okay, so we know power is equal to VI, so I can be written as dQ by dt, dQ dt. So dt you can take this side, P into dt is equal to V into dQ. What is P into dQ? This energy you always remember. What is energy? Energy equal to power into hour. What is your power and how much hour you can sustain? That is your energy. So this is very easy to remember, power hour. So there is a lyrical concept is also there, power hour. So you remember it in this way, power into time is equal to energy. How much energetic you are, that depends. You can start one day preparing, I will start preparing for GATE, and one day you studied for 10 hours. Next day you are push, you came to 1 minute, 0 minute, or you cannot sustain it for long run. So that is not energy. Energy means your power, you should be able to sustain it for long run. Power into how much hour, how much days you have prepared. So that is your energy. That much energy you have. Only one day you are doing something that will not solve the purpose. So you remember energy in that way, power into hour. So because it is power into dt, you can see. So this is energy dW. Because you are taking small time, small interval of time. That's it dW. So V into dQ. Now you can find easily V is equal to dW by dQ. So that is your option D. Okay, now if you come to number 14, in a uniform electric field, field lines at equipotential surfaces. Okay, this one also you have explained so many times. Equipotential surface means suppose this surface is equipotential. That means everywhere the potential is same. So potential is same means you are moving from this place to this place, but potential is not changing. That means you are at level surface. So what was the concept of grade? Grade concept was if you move along the direction of grade, then you will have a maximum change. And if you move along 90 degree with the direction 90 degree to your grade, then there is no change. Because you are moving in this direction, no change. That means grade is something here. Because grade is here, that's why if you are moving in this scalar potential, your potential is not changing. Because you are moving at 90 degree to the grade. If you move in this direction, then there will be the sharpest change in the voltage potential. So if you are moving obviously 90 degree, and what is grade of that potential? Grade of potential is electric field, that we have seen. Grade of a scalar potential is nothing but an electric field. So electric field lines in an equipotential surface obviously should be at 90 degree, at orthogonal. In an uniform, the field lines at electric potential are orthogonal. So they should be 90 degree. So that means you are moving in this direction, there is no change because you are moving 90 degree to the grade. If you move 90 degree to the grade, no change. If you move along the grade, sharpest change. Very important concept for grade. You can remember this one and you can apply anywhere. Then all your logics will come to a good conclusion. So A will be at 14 will be D. Now if you come to 15, the capacitance of an isolated sphere of radius 10 cm is spherical capacitance. You know the formula. It is 4 pi epsilon r. So you put 4 pi epsilon, 4 into pi into epsilon is 8.854 into 10 to the power minus 12 into r. What is the radius they have given? Radius is 10 cm. So 10 into 10 to the power minus 2. In meter you should write. So it is coming 11.11 picofarad. So this is your answer. If you like the video, then press the like button and please give your valuable comments in the comment section.